Hi, my name is Lisa Watts, and my demonstration is over physical science, and we're going to be talking about series and parallel circuits. Okay, class, I want you to look up here at the screen, and I'm going to show you some pictures, and I want you to tell me what you see in them. So let's look at the first picture. What do you see?
A
lot of Christmas lights. What do you see in that one?
Lights.
Lights. It's lighting up the house.
Lights.
A lot of lights. It's lighting up the kitchen.
Lights.
More lights. And what is this?
Light bulb.
A light bulb. So what do all of these pictures have in common? Lights. Where does light come from? Energy. Okay. Where does that energy come from? A power source. Okay, what I want you to do right now is I've got a light bulb, a battery, and some wires, and I want you to try to get them to light up. And work together and discuss what you need to do.
Give me a second.
Talk it out. What are you doing?
Clipping the
Okay.
wire.
And we have light. All right. Can you make another one light up?
Yes.
All right. And we got both of them to light up. What makes the bulbs light up?
Energy.
Energy. Where did that energy come from?
Power source.
Power source. Where on this demonstration, where did it come from? Okay. What I want you to do is in your science journals, I want you to illustrate for me what you did, the steps you took to get the light to light up. Okay? Teacher timeout. From here, I will have the students take their science journals and they will illustrate for me what they did to get light from the battery. Okay, teacher time in. So where did the light come from? How did you get this light to light up? Peyton?
We took the wires and pushed them to the springs,
Okay.
and then we clamped them together.
Okay. Tyler?
Put one wire on a negative spring, one wire on a positive spring.
Okay, and then what?
You touch them together.
You got to what?
Battery and the
If you put one on the positive, one on the negative, what did you do from there?
touch the bottom of the light bulb.
Okay, you put a light bulb in the clip and touched it, right? All right, and you used what two sources?
Positive and negative.
Positive and negative. Very good. Well, your positive is what brings the energy out. It's what brings the power out. And your negative is what takes it back in. So let's look here. We have our wire with our battery or our light, and we put it on the positive. Does anything happen? No. But there is power, however, going from this, from the positive. You just have to have a negative to get it to work. So you have your positive power coming from here, going through the light bulb, and then back into your negative, which goes back into your battery to light it up. And this is what we call a series circuit. Okay, it goes from positive to negative, back to the battery, right?
Kind of like relay team.
Kind of like a relay team. Very good. And in a series circuit, you have your positive, your plus sign, and you have your wire. One wire that's connected to a light, right? And then you have another negative, or you have a negative that is connected to the end. So it's kind of like your start, your end. But in the middle, you have individual wires that are connected to a positive, negative, positive, negative. And then they go down and they light up. Okay, does that make sense? Okay, what do you think is going to happen if I take one of these light bulbs out? What's going to happen to the rest of them? Peyton?
They're going to go out.
Which one? You want to take out or all of them?
All of them.
They're all going to go out because you're losing this source from right here, aren't you? You're losing your positive and your negative source because it was connected with that light bulb, right? Okay. Another form of a circuit is called a parallel circuit. Now your parallel kind of does the same thing. It has your positive and your negative, and you have the wire coming off your positive and negative. But see right here how it branches apart, and then each light has its own wire going to the positive and its own wire going from the negative. You see that? Okay. So what do you think is going to happen when I take one of the light bulbs out of that light? Peyton?
The one light, if you take that one out, that light's not going to go off.
Why not?
Because they both have their own wire.
They both have their own positive and negative hooked up to the battery. Whereas with the series, they're sharing these wires here, right? And here, they have their own. Okay? So we're going to look at some Christmas lights. And I have 2 strands. What do you think? Look the same or different? They look the same. Okay? What do you see? They're all lit up. Okay? Tyler, I want you to take that bulb out. What happened?
They went out.
They all went out. So what kind of circuit is this? Series circuit. So what does that mean? Do you remember?
It means that they all are connected to the same positive, negative wire.
Okay. Well, they're all sharing. They went to positive, negative, right? They all are on a line of wire. Okay. Okay. Let's look at this strand. What do you think? They're all lit up. Okay. Tyler, take that light out. What happened?
Nothing.
Nothing. They all stayed lit. So what circuit is this?
Parallel.
Parallel. So what does that mean?
That they all have their own positive and negative wires.
They all have their own positive and negative wires leading to a positive and negative, right? Okay. What we're going to do now is I want to go over the vocabulary with you and take your time out. From here, I will go over the vocabulary that we just had, positive, negative, series, and parallel circuits, and they will be writing them down in their science notebook as we go through them. Okay, take your time in. Okay, now what we're going to do is we're going to break up into groups, and I have stations already set up to where you're going to create your own parallel circuits. And I want you to take your science notebook with you because you're going to illustrate and describe for me how you worked your parallel circuit, how you got them to come on. And then we're going to come back and you're going to fill out a Venn diagram, or actually a double bubble map. And it's just kind of like a Venn diagram where you're going to compare and contrast a parallel and series circuit. Okay, so time out. I will disperse the students. They will go do their parallel circuits. When we come back, they will do a Venn diagram. That is going to give me, or a double bubble, that is going to give me an assessment of if they understood the lesson or not. Thank you.